And then, if you want to, if it does it in the same way a human does or whatnot, I don't think is super important.
No.
There's probably a lot of learnings from nature in terms of energy efficiency that we can steal.
Right.
And then the rest
That's
is unimportant.
I think that's an interesting point. If we take the human brain, we know it has a lot of neurons in it. It's like 86-ish billion neurons, but the number of synapses is at least like times 100 or 1,000. So that means it's significantly more than the biggest kind of number of parameters that any kind of model have today. Still, we potentially have a more powerful way of training LLMs than human brains has, because you can feed in all of the data of the internet and it can actually use it and come to some kind of knowledge or fact that you can
and process
recall.
a lot in parallel.
Yes. What you cannot do with LLMs today, at least not in the training phase, is to very, very quickly learn how to do something, right? Because a human, if I tell you, Jesper, this is the way you should chug a beer, and I give you some tips, you can, by a few examples, learn how to do it.
Can I challenge that? I wonder. So, I think the human brain has a number of biases that serve it very well within the context within which we operate. So, for example, we have some parts of our brain that are specialized at navigation. And in particular, they're specialized in two-dimensional navigation because the surface of the Earth is two-dimensional. And so if I were to give a couple of examples of rotations of spinners, it might not feel super intuitive to people, whereas Euclidean 3D stuff would feel super intuitive.
Sure.
And so I do think humans are super intuitive on human stuff, on throwing rocks in the savannah. I'm not sure it extends to general cases.
Yeah. Okay, so perhaps there is a bias in our brain for the Euclidean kind of physics that we have in the world. And if you want to learn how to ride a bike or a car, you don't have to run over the cliff 1,000,000 times before learning not to do it.
Yeah.
But it's also because you have the physics like either like a prior in the brain, or it's simply because you as a child, are learning the physics, like Jan Liculis would say, in a very self-supervised kind of way.
Yeah.
And you can use that kind of understanding of the physics of the world to learn new tasks much more efficiently.
Yeah. I think there's a lot of cross-domain knowledge here that is really beautiful, from biology to physics to computer science and everything. And everybody always makes fun of each other for not knowing these things, but it's not easy to know. For example, I was chatting with ChatGPT trying to understand how a baby deer can learn to walk as soon as it's born. And apparently there are these nerves that oscillate, and there are harmonics in the oscillations that they just happen to move you in a way that becomes like a gate. And a gate is a very knowable thing. For example, we know the best way for a spider or an insect, even a spider, arachnid with 8 legs, we know the best way for it to walk. Yeah. And you can encode that with a very minimal number of neurons that oscillate in a fixed way. And so you think that it's this, a baby deer doesn't need a lot of training data to walk. Well, no, but it doesn't need more than a couple of neurons either. And that's something that evolution could have created. And it is okay to be a little bit humble to the power of gradient descent, so to speak.
Yeah, but can we move to that? Because
Are you saying that evolution moves by gradient descent?
Yes, with death as the fitness function.
Okay, this is the interesting one. But if we take Geoffrey Hinton, he's one of the 3 godfathers of deep learning, and had the Turing Award and everything. He's worked at Google for a long time, and he just retired. And he retired for a reason, saying he's getting increasingly scared about the dangers of AI, and he has been studying neuroscience for a really long time. That was really what he started with, and he said basically, if I want to understand the human brain, I need to build it. And the way for him to build the human brain is to do AI. So his goal really was to try to understand the human brain. And by doing so, he invented the backpropagation and the way to train these kind of models by gradient descent. And then he suddenly said, and please correct me if you don't agree, but what I heard him saying is basically, I think the way AI trains today is much more efficient than the human brain. And that scared him suddenly. And then, he recently said, these kind of backpropagation techniques is obviously, we know that's not how the human brain works. So it's like a approximation, something we do to this is what we can do today. But then suddenly you can flip and say, actually this is much more efficient than the human brain.
Yeah.
That means that we can suddenly build something that is learning stuff much more efficiently than the human brain can. That can be scary.
Yeah.
Would you agree with that kind of thinking? That's
I mean, I think it's fun to think about the ways to use human brains as inspiration for new methods, but what we have is sort of unreasonably effective. So it's like
the human brain?
No, I'm talking about transformer. The
Transformers, yes,
the
okay.
transformer architecture seems to be, in a way, even though it's very costly to run and not energy efficient, etc., it's still the scaling laws are so attractable. It's so attractive if you're thinking about it from like a business perspective. It's amazing to have something like that. You can just follow the trend until it bends, and then you're fucked. But up until that, it seems to be working well for us.
Nature has to balance a couple of things. So I was once looking for like a very good example of what can you do when you have an IQ of something like this. And so for one standard deviation, you can do first order theory of mind stuff, and for 2 standard deviations of IQ, you can do second order, which means I can guess what you're thinking that I'm thinking that you're thinking. That's 3 orders of theory of mind, and that would require 3 standard deviations of IQ to do, and so on. The human brain has very little use in general for 4th order theory of mind sort of guessing in social contexts. So why would it optimize for that kind of intelligence when power efficiency and a bunch of other stuff might be more useful in social context and that kind of stuff? And so it's only reasonable to believe that AI should be able to, we can just make absurdly efficient at learning AI systems. But I think I do agree with you that AI can learn faster than us. And I think what people miss or underestimate is how similar we are. So for example, there's lots of really cool examples of, I think the bad thing to show is how similar AI is to us, and it's better to show how similar we are to AI. And my favorite example of it is, remember in the beginning when image classifiers made mistakes from adversarial examples? You would show it a picture of a penguin and it would say banana, and you're like, oh, AI, stupid AI. As it turns out, there's, you might have seen it, there's a paper of a team that shows a human a picture of a water bottle and says, is this water bottle a train or a dolphin? And you'll say, it's 50-50, either or. And you can adversarially change the pixels to sort of force a human to 15% more classified in one direction or another. Imperceptible pixel changes, which means, and presumably if I could fine-tune it to your specific brain, I could push that even further. And I imagine a future where, imagine movies, the death scene, it forces you to cry and you don't even understand why, because it's fine-tuned to your brain.
I mean, there are so many optical illusions that the human brain gets so wrong, and it's amazing how many bugs we have in the human brain. And I think sometimes people don't speak enough about the limitations of the human brain. I still think of course human brain is significantly superior to the AIs that we have today, but still it's worth, I think, just reflecting, so to speak, about the limitations of the human brain. And for one, our memory is horrible. It's easy to see that the LLMs have superior knowledge in orders of magnitude than any single person in the world. We can also see that our limitation in reasoning in the number of steps backwards or forwards is also limiting.